This is the final of the asynchronous lectures for week 15 in Discover Geography. Please remember that we will have class the Monday, the last day of class, and we will discuss the final exam. In this last video, what I'd like to discuss are concepts of mitigation and adaptation in response to climate change. And again, we go back to the concept of extent, magnitude, and rate. What we're saying with that is we have to understand how climate change is happening in order to respond to it. Now, first of all, I want you to understand what these two terms mean. First of all, when we say mitigation, these are any strategies that human beings adopt that will reduce or eliminate processes that contribute to climate change, and that is the emissions generally of greenhouse gases or the reduction in those things that affect how carbon dioxide and other gases are removed from the atmosphere. The second part of this is adaptation. That is, we know that climate change is already happening. How do we change society, that is, modify the resilience of our society? Strategies that increase social, economic, and ecological resilience, that is, the ability to accommodate different changes in climate. So one way we kind of look at this, and I want to kind of put this, this comes out of the Japanese Environmental Agency, essentially the equivalent of our Environmental Protection Agency. And in this, what I want you to think about is the idea that we know that greenhouse gases are increasing. Okay? CO2 emissions, methane emissions are increasing. If that's happening, what can we do to mitigate that? In other words, to reduce the sources of those greenhouse gases or find ways of taking them back out of the atmosphere. Now, once those are in the atmosphere, though, and again, it is happening, climate changes. So we see that there's going to be an increased change in temperature. Temperatures are going to go up in general, although that's certainly not even. And the timing and extent of precipitation is going to change. We're also going to see sea level rising. So when that happens, then societies have to adjust, and that is what we mean by adaptation. So how do natural systems adapt, and how can human beings, in a sense, mimic that? Now, one thing that is happening is that societies, governments, are responding to the concerns for global climate change. And one of the things that's happening is that there have been historical efforts to reduce greenhouse gas emissions. The Paris Climate Accords in the earlier part, 2015, 2016, in terms of when they were moving through, many countries pledged to reduce their current emissions. And if you look at this across a number of different countries, the initial pledges, this is what we see here in the purple, those are really the Paris Accords. And then what has been pledged during Glasgow, which is the most recent meeting. And what you'll notice is that the pledged amounts of reduction or mitigation do not come anywhere near the need, and most scientists would say that we really need to get to 1.5 degrees Celsius total global warming in order to avoid the most significant impacts of climate change. And so, again, this is where China is. You'll notice the United States pledged are quite a bit, quite significant, but still not enough to get us to that 1.5 degrees Celsius. European Union, they're pledged, and current policies get them here, but again, nowhere close. And then you have some countries that have actually said they're going to increase their emissions. They need to do that in order to meet their social and economic goals. So one aspect of mitigation is done at a national level. And so what we have to ask is, well, okay, what are the things, what are the factors that influence the production of greenhouse gases? And it's actually quite straightforward when we understand what emits what. And so in terms of globally, what we say is that the largest contributor of greenhouse gases is the production of electricity. The burning of fossil fuels to produce electricity represents about 1/4 of the greenhouse gas emissions. And again, this is burning of coal, natural gas, and oil in order to produce electricity. Coming in a close second, though, is food, agriculture, and land use. Now, food, agriculture, and land use, we need to understand, we eat certain types of food, most notably the eating of animal proteins, most importantly beef, produces a large amount of methane. Cattle production produce a huge amount of methane, which is really a significant factor in terms of greenhouse global warming. But coupled with that is a changing in land cover. One thing that we often don't realize is that trees, especially forested areas, and in fact any natural vegetation, plants take carbon dioxide out of the atmosphere and convert that into their own biomass. And in that way, in a sense, we're taking carbon and we're storing it, or sequestering it is the term for it, in that plant biomass. And again, a tree may store that carbon out of the atmosphere for, in some cases, hundreds of years. So the combination of producing meat and all the methane that is associated with that and the carbon dioxide that is associated with that and changing land use almost equals what we do in terms of electricity production. Then, of course, in the other ones, we have significant components, industrial activities, our transportation, the amount of carbon dioxide and carbon monoxide emitted from our individual vehicles, the way our buildings work, in fact, what they're made out of and how they use energy. And then there's a whole slew of other somewhat minor ones that occur. So this is where it comes from. So if we are going to mitigate, we have to deal with these. Now, one of the core ideas here is how do we change our energy production? And the burning of fossil fuels is the largest contributor. So one mitigation strategy is to change how we make electricity. And it's important to note that if we look at just the United States, we actually have a diverse range of strategies, but they don't work everywhere. And that's my main point that I want to make here. And so what I'm going to do is I'm going to go through a series of maps, and you'll notice right now we're looking at this, and this is photovoltaics. That is, if you think about solar panels, photovoltaics convert sunlight directly into electricity. But in order for that to work, you have to have a lot of sunlight. And it only makes electricity when the sun is shining. So you have to have a way of storing that electricity, obviously, for the nighttime. Now, we can also, though, use something called concentrated solar thermal. Concentrated solar thermal also uses sunlight, but in this case, it uses mirrors to concentrate that solar energy into high temperatures, oftentimes either working on water, boiling water, or other materials, oftentimes sodium, for example, that is used to store that heat and use that, again, to boil water to produce electricity through turbines. But again, you'll notice that these areas are particularly good in the Southwest. Unfortunately, there's not a lot of people here. Now, we also, and many of us are familiar with wind generation. We see wind generation, again, these are the large windmills that we see across the landscape. And again, windmills are quite effective in many areas. You'll notice quite a bit of the United States has a high amount of energy potential in terms of wind generation. In fact, in our area, right off Lake Erie, if it was offshore generation, would be really quite effective for this. The Great Lakes in general, and the Midwest. We also have the potential to develop biomass, that is converting plants into either ethanol, that is an alcohol, or burning them directly to produce heat, again, boiling steam, or boiling water creates steam, electricity generation. The downside, of course, to biomass is that it's a choice to either grow things for ethanol production or for food. And anytime that you burn biomass, you are in fact producing some carbon, although not nearly as much. We also have geothermal. That is a strategy of using ground heat. That is, deeper you go in the ground, the warmer it gets. And we can use that for heating, not necessarily for the generation of electricity, but overall in terms of heating buildings. And then, of course, we have hydropower dams. You have to have a river, and you'll notice in Pennsylvania, there are quite a number of places where hydropower potential is present. In the similar manner, we have wave action. We can actually generate electricity through the actions of waves and tidal energy generation. The point here is that many different types of energy strategies are available across the United States and in fact across the world, but not every place has the same kind. Right now, if you think about energy in the United States, by and large, it's generated in very few ways. You have coal-fired, you have oil, natural gas-fired power plants that generate electricity, or you have nuclear. We do have some hydro, but by and large, it's a uniform system that moves electricity all through the landscape. The biggest challenge for all of this is how do we store electricity when the wind's not blowing or the sun isn't shining, and that is a challenge. Now, we can also think about this in terms of all of these things contribute to our potential energy. And in fact, if we combined all these in the United States, we could meet our energy needs. So mitigation is possible, but it's expensive. All right, now governments have looked at this and said, well, there has to be some overlap between those. And remember, mitigation is those things that reduce the production of greenhouse gases or increases their sequestration, their storage. And so if we think about mitigation, for example, mainly we cut down on greenhouse gas emissions. How do we do that? Well, we could change how we generate electricity. We could change how we move around, in other words, what type of transportation we use. We can, again, balance. Are we becoming more energy efficient? Are we producing energy a better way? Or do we become more efficient in all of these things through industrial processes? In other words, can we make factories more efficient so they don't need as much electricity? So the strategy in terms of mitigation is oftentimes to combine changes in how we produce energy with increasing efficiency and, in many cases, changing how energy is delivered. Now, adaptation means that we have to accept that some changes are going to occur. That is, we have to change how we live our lives, assuming that the climate is going to change. And if you think about this, some of the major ones, of course, are we have to understand that we're going to have hotter summers, and in many places hotter nights, and how do we accommodate that? Well, one adaptation, unfortunately, is often to move, to get out of the way. We have to also have built into our infrastructure greater resilience to our extreme weather events. And in many cases, we may have to find ways of changing what we grow. And so again, many different ways of adapting to climate change. Now, I want to end this last lecture with the idea of what you can do. And it is important to understand that different things have different impacts. I am by no means suggesting that anyone needs to abide by these adaptations. What I simply want to point out is that there are things that we can do that do have a significant impact. And again, understand that all of these are personal choices. The other thing, though, is that people sometimes say, well, there's nothing I can do. And that really isn't the case. There are a number of things that you can do that have some impact. Now, most notably, there are some things that people often say, do this, and some of them really don't have much of an impact. For example, the reality of changing out your light bulbs in your house. Very low impact. You can do it. It's great. You're going to save energy. It might save you some money. But it really doesn't do a lot in terms of reducing how we are affecting that mitigation side. And again, this is important. These are things you can do for mitigation. Now, there are other things that you can do that does have some moderate effect. For example, the more you use cold water in terms of your washing, that's good. And not using a dryer. Okay, these are things that actually use a fair amount of energy and that we don't really need to do. It's more of a convenience issue. Those are things that are important. But now, if you really want to make a difference, these are the important issues that we have to ask. First of all, one of the most direct and fairly straightforward and, in fact, lowest cost options for anybody is to eat less meat. Going to a plant-based diet in terms of the effects on climate change is one of the most significant and lowest cost options for anybody. Eating less meat really does make a difference. Now, the reason I emphasize that one is that it doesn't really cost you more to eat a plant-based diet. In some cases, there's a little bit more of a cost per calorie, but not much. That's far easier to do than, for example, switching to an electric car, which may cost you $30,000 or $40,000, or simply not driving a car. Now, again, for many of us, that's not an option. There isn't an infrastructure of transportation. Other ones, though, that really do have an impact, for example, not if you are someone that flies, fly less, flying less international transportation is a significant impact. And these days, it is an amazing thing how much more by telecommuting we can change how much energy is consumed. Now, of course, at the other end of the spectrum, kind of the extreme example, less children. Fewer people, less consumption. But again, these are some things that are, having a child or not having a child, that's a personal choice and a very significant one. Choosing to eat plant-based diets, much more straightforward. Okay, I'm going to end this lecture now, and there is a second video that I would like you to watch that is the implications of the magnitude of change that we're going to experience. So again, please watch the third video. That will be part of some of the exam questions. It is important that you watch that. We will talk again on Monday, last day of class.